Now, before we continue, let's do another example. So in this case, we have density of air, which is 1.3 kilograms per meter cubed, and now they want us to change to some random units called slugs per feet cubed. Okay, and given is that one slug is 14.59 kilograms and 1 meter is 3.28 feet. Now this is a little bit more complicated than the last expression, and what we are going to do is we are going to do this in two different steps. So in this case, the density of air is given to us. So the density of air is given. Density usually I will express as rho. So I'm just going to write rho air is equals to 1.3 kilograms per meter cubed. Now, I would recommend that during the course of this semester, please do not write kilograms per meter squared like this, kilograms per meter cubed like this, because it's going to make figuring out what the correct units are a little bit more difficult. I mean, you could do it, but I would recommend that you don't. And you just write kilograms per meter cubed this way, so it'll make your life a little bit more simpler. Okay, so now what else is given to us? Well, given is one slug, SLUG, is equals to 14.59 kilograms, and we are given 1 meter is equals to 3.28 feet. Now, how do I convert the given value into slugs, SLUGS, per feet cubed? That's my problem. So this is the question, right? This is my question. Okay, now how do I do this? So first of all, I need to convert kilograms into slugs, right? One slug equals 4.59 kilograms. So I'm going to write 1.3 kilograms times, I want to come up with an answer in slugs. So I'm going to rewrite this as that. Okay? One slug equals 14.59 kilograms. So that's what I'm going to write now. One slug equals 14.59 kilograms. Okay? So that takes care of my kilograms. Kilograms get canceled. I get my answer in slugs. Okay? Step 2. I need to convert meters cubed to feet cubed. Given that 1 meter equals 3.28 feet. Okay, now this becomes a little bit tricky, so be very careful when you're doing something like this. What we're going to do now is instead of writing meter cubed, I am going to write meters, dot meters, dot meters, right? Meter cubed equals 3 meters. So in this case, I need to get rid of my meters, meters, and meters, right? And I know 1 meter equals 3.28 feet. So I need to get rid of my meters, which is now in the denominator, so I'm going to put my meters in the numerator, and I'm going to come up with feet. See it? And this is what I want towards the answer. Given 1 meter equals 3.28 feet, right? So 1 meter is 3.28 feet, right? This means I have to do this times 1 meter divided by 28 feet times 1 meter divided by 3.28 feet. Okay? Over and over again. So watch carefully. What happens now? 1 meter gets canceled with 1 meter. 1 meter gets canceled with this meter. And the third meter gets canceled with this meters. And what is my answer going to be? Slugs per feet, per feet, per feet, which can also be written as slugs per feet cubed. So your answer is going to be slugs per feet, right? And how do we do that? It's going to be 1.3 times 1 times 1 times 1 divided by 14.59 times 3.28 times 3.28 times 3.28. And a little bit of a calculation should give you an answer in slugs per feet cubed. Quickly, do the math. What's the answer? My answer comes out to be 2.5 times 10 to the minus 3 slugs per feet. If you would like, please go over this example one more time and convert it to something else and see if that also works for you. Okay? Some of the examples of derived SI unit could be the unit of energy, which is the joules. Basically, we know joules is equals to newtons per meter, where newton is a unit for force, which is also a derived unit, and all of those can be expressed in terms of base units. Now, this is another slide that becomes very useful to come back to and look at. So, for example, area units are meter squared, and its base units are meters. Frequency is cycles per second. The symbol for frequency is hertz, the unit is hertz, but in terms of base units it's 1 over s. So basically from this definition you can figure out that the frequency is actually equals to 1 over time. So the relationship between frequency and time is 1 over t. Density is kilogram per cubic meters. Force is in newtons. Pressure is in pascals, and power is in watts. So please have this slide as a reference point so you can come back and look at this slide again and again. Only a few countries in the world do not use SI unit, and those include Myanmar, which is in Asia, Liberia, which is in Western Africa, and United States. All other countries of the world have pretty much switched over to SI units.